Thanks very much for joining us. Even within established businesses, data has a skyrocketing importance in value creation, according to McKinsey. And now enterprise systems, including SAP, like which Peter have demonstrated, can leverage this so-called man and machine approach to enriching master data and therefore improving its value. Now, just a reminder, folks, that we have a chat function here in the GoToWebinar software, and at the end of this section, I'll also suggest how you can get started with your own innovations around machine learning. So in this second part of our time together, I'm going to share with you some observations about AWS and manufacturing, then AWS and machine learning, and I'll explain how SAP customers are modernizing and innovating with AWS. And thanks, Kristen, we're at the right slide here. Thanks very much. So manufacturers are telling us that they are facing a number of challenges, but there are also some exciting opportunities. And particularly in these trying times, there have been some significant interruptions to supply chains, and the availability of components and distribution networks have been somewhat volatile. Many manufacturers have, in fact, suspended production and only recently resumed. In some industries, customer demand has hugely increased, and in other industries, it's significantly fallen. It's not easy, right? Now, looking past these current challenges, the protection of intellectual property around products and processes and customers has never been more important. And in long term, some manufacturers are retraining staff and are redesigning some job roles, and these can be called so-called new collar workers. Finally, most manufacturers that I'm familiar with have a long-term strategic focus on year-on-year cost optimization in their operations. Next slide, please, Kristen. Thank you. So at Amazon, we like to think about mechanisms, and one of those is a flywheel. And a flywheel can be used to illustrate a continuous improvement process. In manufacturing, we can broadly identify three sources of data from the factories, from the products, and from the business processes. And according to this flywheel concept, for example, improving factory operations can improve the quality of the finished product. Collecting and analyzing data from customers about how they use the products can improve the product design process. And then those improved product designs can then yield improvements in, say, the manufacturing process and perhaps give you the opportunity to decrease the number of assembly steps. However, overlooking these relationships between the different sets of data and this concept of a flywheel, however, has a cost. And I recently met an automotive manufacturer who has effectively lost track of the exact location of plant machinery. And because of that, they're writing off more than $5 million a year in spare parts. And that's because the plant maintenance staff can't effectively complete scheduled maintenance work. Next slide, please, Kristen. Thank you. So to help manufacturers better address these challenges, AWS has devised an extensible reference architecture, and that's shown on the screen in front of you. So on the left-hand side, we are illustrating in simple terms a factory environment, and most manufacturers have a desire to have smart manufacturing control systems, and they are deploying IoT technologies, that's Internet of Things technologies, and that either is connected or occasionally connected. And many times there is a requirement for compute and processing at the edge. Other manufacturers have a requirement for low latency and very high performance, and for that reason we have solutions including Amazon Outposts, which provides for compute, databases, storages and more in one's own data center or adjacent to the manufacturing execution systems. In the cloud, we have a number of services which come together in this extensible reference architecture, and at the center is a data lake. A data lake can ingest data, either structured or unstructured, from multiple sources, including from the manufacturing systems, from IoT systems and more. At the bottom of the chart, we're illustrating here that systems of record, including SAP, ERP, or CRM, or supply chain, or product lifecycle management systems, all of these can run in Amazon Web Services and take advantage of services like Amazon EC2, and can be extended with our services, including our API gateway. On top of the data lake, customers in manufacturing are deploying a number of services to do analytics and data warehousing in new and different ways. And on top, again, customers are innovating and making use of the data in the data lake for innovations around machine learning, IoT, and more. Next slide, please, Kristen. Now let's dive into machine learning. Next slide, thanks. Tens of thousands of businesses have used AWS for machine learning for really fascinating use cases around healthcare and new customer experiences, personal mobility, and more. But even within established businesses, data has a skyrocketing importance, and it now means that enterprise systems, including SAP software, can leverage the so-called man and machine approach, such as which Peter demonstrated earlier. Next slide, please, Kristen. So Amazon itself has been innovating on behalf of customers for many years using machine learning. And if you're an Amazon.com customer and you've used the recommendation engine, firstly, thank you very much. But that is, in fact, an example of machine learning. Amazon.com also uses machine learning, for example, in our significantly automated fulfillment centers. And we do, for example, image recognition to keep track of fulfillment operations and pick and pack. The Amazon Echo is a widely used device, and it includes machine learning. In fact, the same voice processing service inside Amazon Echo, Alexa, is also available as an Amazon Web Service. So Amazon has been innovating on behalf of customers around machine learning, but also we see that machine learning has become pervasive in lots of different industries. Next slide, please, Kristen. Thank you. So at AWS, we want every developer or data scientist to be enabled and productive with machine learning. Our service portfolio can be illustrated with 3 layers, and they have different layers of abstraction. So if I could draw your attention to the bottom of the chart, it starts with machine learning frameworks and infrastructure. So all of the major machine learning frameworks, PyTorch, MXNet, and TensorFlow, can be deployed on AWS. And there are also a range of machine learning optimized compute services known as Inferentia, and these offer the best price performance of any cloud. Second, Amazon SageMaker is a fully managed service, and it provides every developer or data scientist with the ability to build and train and then deploy machine learning modules quickly. SageMaker has the advantage of removing the heavy lifting from each step of these machine learning processes, and it makes it much easier for you to develop high quality models and get results immediately. At the top of the chart, we have a number of artificial intelligence services, and these are mimicking human cognition. And for example, we have Amazon Recognition for image and video classification. We have Textract for doing document recognition and optical character recognition. We have a service called Poly, which enables you to do text to speech, and Amazon Forecast, which is for time series forecasting in at least 6 domains. Now, I've gotten hands-on with 3 of these artificial intelligence services, and I can assure you that you do not need to be a developer to be productive. If you know your data, you can in fact be productive with these artificial intelligence services. Kristen, next slide, please. So we talked about manufacturing and machine learning, and now let's consider SAP software, which is used by thousands of manufacturers. I can share with you today that more than 5,000 customers in all industries run SAP software on AWS, and half of those run SAP HANA-based workloads. Thanks, Kristen. We're at the right slide here. AWS has been innovating with SAP and on behalf of customers for 11 years. SAP became an AWS customer in 2008, and in 2011, they certified AWS as the first cloud platform for production deployment of their applications, middleware, and databases. At Sapphire now, 2019, Hasso Plattner, who is one of the remaining founders of SAP and active in the company, announced that the new SAP Data Warehouse Cloud Service will be available first on AWS. Next slide, please, Kristen. Thank you. Application architecture has evolved, and rather than monolithic applications, which are designed to support many functions and where you have a high impact on change, a microservice architecture is being adopted not just by digital native businesses, but also established businesses and enterprise. And it can be identified by functions which do one thing, and these can be scaled or deployed or changed independently. And so we see more and more customers adopting an architecture that resembles this approach, which you see illustrated in front of you. At the bottom, there is an infrastructure layer, and it's built to last, and it includes the foundations around security, compliance, and management. Then there's an application layer that is built to consume, and it can include either contemporary or previous versions of SAP software and a data lake. The differentiation layer is comprised of microservices, and the early adopters of this kind of architecture have taken a hybrid approach, and they're using both AWS native and the SAP Cloud Platform services. Next slide, please, Kristen. Thank you. Now, being customer obsessed, AWS believes that SAP customers, including in manufacturing, should choose their own path around modernization and innovation. And let's consider some examples. Customers including Petronas Lubricants and ABM Investama from Indonesia have successfully deployed SAP S/4HANA on AWS. SAP and AWS together are innovating around S/4HANA Move, which has offerings including the SAP Model Company, and this can be illustrated with the so-called purple path on this chart. However, the orange path illustrates how customers, for example, Ayala Land from the Philippines and Contact Energy in New Zealand, have converted their data and migrated to SAP HANA, but they're continuing to run familiar versions of the SAP applications. And then finally, the green path on the left here illustrates that customers including Pacific Interlink from Malaysia, Cinemas Group, Viver in Indonesia, and Visi Industries in Australia and New Zealand, they've all modernized SAP by completing a lift and shift migration to AWS. So regardless of when, how, or whether you're considering adopting SAP S/4HANA, AWS Cloud can be used to innovate around data lakes, IoT, and APIs, and machine learning, like what Peter's demonstrated for us. And these innovations can support use cases to improve customer engagement, employee engagement, and of course, smart factories. And so there are now more than 5,000 customers running SAP workloads on AWS, and half of those are running SAP HANA-based workloads. There are leaders in every industry, and in manufacturing, this includes Hoya and Keiwa Kirin. It includes RPG Seat, LTI, Visi Industries, Komatsu, and more.
A little bit about Utopia before I sort of talk about what we've done with the AWS and machine learning. If you go to the next slide, please, Kristen. Utopia was actually founded in 2003. In actual fact, we were founded on 03/03/03. So interestingly, it doesn't matter where I am in the world. That date means the same thing. We're about 500 employees worldwide, and we have a very large R&D team that is focused on developing master data governance solutions. We focus on 4 areas, predominantly around data strategy, where we help people work out what their strategy should be for their data management across people, process, and technology. We do data governance implementations, so we actually implement SAP's MDG in both the core domains of business partner, finance, material, and also very specifically in the EAM domains and in the retail domains. We do a lot of data migration work, helping people move from non-SAP systems to SAP, and also move now from older SAP versions, ECC versions, onto S/4HANA. And many of those migrations now are being done up onto AWS private cloud hosting solutions. And we do a lot of work on the data quality, data profiling, data cleansing, data enrichment. And what we're going to talk about today is specifically around the work that we're doing using machine learning in the data quality space. We are SAP's preferred partner when it comes to EIM solutions such as data services, information steward, SAP MDG, and we also develop software for SAP and extend the SAP MDG solution to cover enterprise asset management, so all of the objects that are in the SAP plant maintenance module, asset information workbench, and MDG for retail and fashion management. All of our development environment is actually hosted on the AWS cloud. So we have well over 100 SAP servers up and running on AWS, and we also run our machine learning engine up on AWS. If you go to the next slide, please, Kristen. Whilst we have a large customer base in Asia Pacific, and you can see some of the people that are there that are our customers in Asia Pacific, we are actually a global organization. We operate across most of the continents, I think every continent except Antarctica. Our headquarters are actually in Chicago in the US, and our R&D development team is situated in Bangalore in India, and we have offices around the globe. Most of our customers are large customers, and many of them are SAP users as well. So if you want to understand about what we're going to talk about today, about why Utopia, if you go to the next slide, please. What we find is that many organizations have data spread across multiple environments, and many of them are not electronic databases, they're not ERP systems, they're not any sort of system. They're in searchable PDF documents. They're in handwritten documents sometimes. They're in documents with pictures and images, or they're scanned documents. And we use our machine learning capability to actually extract information out of these unstructured formats and get them into a structured format that can be used by computer systems. We also find, next slide please, that we have a lot of people have data in their systems, but the descriptions and everything are random. They're like all over the place. There's no form or fit or structure to them. So what we do is we actually take those random structures and we convert them over to standardized structures, as you see here, so that now everything is in the same order. Everything has a nice format to it. We've removed manufacturer part number from the descriptions, and when people are searching for their items, now they have a very structured format that they can use for their searching. And even the most advanced fuzzy logic searching engines still work better if you give them nicely structured and standardized data. So they still work better if you give them that sort of data. Next slide, please. We also find that in many cases, our customers have minimal information about their parts that they have in their system. So they may have a short description, they may have a long description. And what we do is we actually use machine learning and our automated enrichment process to go and provide them with a lot more data that they can actually use in their system. Next button, please. Right, so we can then take that from just the information that was provided. We can go and provide a manufacturer name, a part number, a URL where you can go and identify the information for that part, a more structured short description, long description, UNSPC codes, and then of course all of the characteristics and the characteristic values associated with that. So now you actually have a complete set of data that you can use within your system. So how do we do all that? Well, we do all that using a very structured approach. And what we found is that when we first started down the machine learning path, that we tried to do it all in one hit. We tried to do it all in one step. But we soon realized that just like human beings, machine learning algorithms are, some machine learning algorithms are better at doing certain things than others. So we actually started breaking the process up into individual steps and using the best machine learning algorithms in each of the steps. Next slide, next button, please. When we first started doing this, we actually were using manual cleansing efforts. So we had a lot of people, basically a lot of effort went into it, very little computing power and not much IP. It was basically all being done based on the knowledge of individuals. We progressed to the expert rule-based stuff where we're starting to using ETL tools, SAP data services, data flux, those sorts of tools. So the amount of effort, manual effort that went in changed a little bit, went down. We certainly needed more computing power and we started developing some algorithms to do that. Now we are at the data mining based part. Now we're starting to use the machine learning capability that's available. The effort is less, but it's a different type of effort. Now, not only do we need subject matter experts that understand the data that we're processing, but we also need data scientists. We also need people that understand all of the different machine learning algorithms that are out there and what they're good for and what they're not so good for. The amount of computing power has gone up dramatically. The machine learning servers that I have running on AWS are the largest of the servers that we actually run, and especially when we're doing the training of the machine learning algorithms. And of course, the amount of intellectual property that we're now using has gone up. But the beauty of this is that now we can automate a lot of this. But I think a lot of people sort of have got this notion in their head that you can have like the dirty data washing machine, right? Where you can feed dirty data in one end and you get clean data out on the other end. It doesn't work that way. You really have to spend the time to train these engines, to get them to understand exactly what sort of data you've got. And that's the advantage that Utopia has had. Utopia has been doing this for over 18 years. So we have a very large training database that we can use where we can say, this is the dirty data, this is the clean data, and we've trained the machine learning algorithms using that training data to be able to get these algorithms to output really good quality data automatically. If you go to the next slide, please. So why AWS? One of the reasons we use AWS is because of the breadth of the machine learning algorithms and so on that were available on AWS. We did an extensive evaluation of the different platforms that were available, and we actually then decided that we would go and use the AWS platform. One of the good things for us is that AWS has taken some of the raw machine learning algorithms and put them into packages. So they're pre-configured that you can use some of them like recognition and text extract, etc., where they've used natural language stuff to be able to extract data out of documents and so on. So those sorts of things we've made use of in our application for doing this machine learning. So if you have a look at how we've actually put that together, if you look at the next slide, please. What we've basically got is we've got all of our machine learning stuff run on AWS. We've got it integrated with different applications on-prem and so on. We have a user interface. In this case, The user interface that I'm going to show you today is coming from SAP's Asset Intelligence Network, or AIN, which is their cloud-based intelligent asset management application. We actually have running everything on SUSE operating system, and we're using Docker to be able to compartmentalize our applications. We have a reference architecture that includes all of the algorithms and everything that we put together. And as a new user starts using or triggers the machine learning, it goes and creates an environment for that specific user. So whatever that user is running the machine learning algorithms, they're working on their own copy or mirror of the machine learning. As the next user comes on, they're also using their own environment. So that way we don't have conflicts when different users are using the machine learning algorithms at the same time, and we can actually extend that to n number of users. If you look at what's actually happening within those environments, the process that's being followed. Next slide, please, Kristen. The process that's been followed when someone triggers the machine learning algorithms is fairly complicated, right? Next button. So they're actually triggering a whole range of processes. They're doing some access via an API that we've developed. There's a whole data pre-processing module that allows us to prepare the data before we run it through the machine learning algorithms. We then do feature extraction. We actually apply the various algorithms that we've got, and we iterate until we get the optimum model. Then we go and select the models, and then we build what's called a model ensemble. And this is a very important aspect of what we do. What we've found is that machine learning is still statistical, right? You still don't get a 100%, I am absolutely certain that this is the answer result from most of the machine learning algorithms. There's still a probabilistic answer. So what we've done is we've said, well, let's use 2 or 3 different models and see what answers we get from the 3 models. And if we get the same answer from the 3 models, then we know that we can have a high level of confidence that the answer is correct. If I get 2 out of the 3 the same, then we say, okay, we're pretty confident. But if I get 3 different answers from each of the models, then we need to go back and have the human touch. This is where the human subject matter expert comes in and can say, hey, let's go back and review the model. Let's go back and review the data. That way we are able to automate the process from end to end and have a high degree of confidence that the final result we get out at the end is the correct result. All right. So that's a process that we're building inside our machine learning engine. So if you go to the next slide, please, Kristen. We're going to do a demo now, a recorded demo of part of what we're doing. So this is actually running in SAP's Asset Intelligence Network, as I said. We've actually created an application where you can go and you can load a picture of an equipment nameplate and create an equipment in SAP's Asset Intelligence Network. So this is the only typing that you need to do. Put in an equipment ID, put in a description that you want to give it, and from now on, basically all you're doing is mouse clicks and letting the machine learning engine do its stuff, as they say. Now we will go and upload a picture of the nameplate for an electric motor. In this case, a Baldor VL3510 electric motor. Yep, so now uploading. So when we go and upload this, it's actually going and processing the pic, and it is actually taking out information like manufacturer, part number, model number. It's assigning a class. It's actually going and splitting out all the text that it gets from the picture and assigning it to as values to attributes. So you can see that it actually has gone and done the scan text. It's now done the attributes. If you have a look at the picture, it will actually show you where it got the information from. Highlights that in bright blue. it takes the text. It then takes that text and assigns it to a class, in this case motor AC, and then it takes all the values that it found and it assigns them to attributes, and now it will actually go and create an equipment in Asset Intelligence Network. So it will go and create the actual equipment record. You can see the little message that says the equipment's been updated. When we go and refresh this information, it will actually then show you that the attributes have been filled in. So 6 attributes, no attributes without values. We can see all of the values, all of the attributes here. And we can also see in which manufacturer, what model's been created, what template's being used, the serial number, manufacturer part number, and so on. All that information has been populated. And if you need to go and check something, it is also attached, the document or the picture to this record as well. So you now complete the audit trail to say, well, where did I get that information from? So you can see basically without having to type in any of that information, we've now created a equipment record in AIN. All right. Next slide, please, Kristen. In addition to actually doing that, we're actually using the machine learning algorithms as well to go and do web scans and find additional information about equipment and materials. In this case, we're going and finding alternate suppliers for a bell door motor, right? We can also go and find alternate manufacturers for a motor that has the same form, fit, and function. So let us go and find a motor that is the same, that can fulfill the same role. And once we've actually found them, then we can actually go and say, okay, now let me go and find additional suppliers for these particular motors as well. So next slide, please, Kristen, where you can actually now go and provide that. So we are now able, once we've identified one of these pieces of equipment, to go and find alternate suppliers for the same piece of equipment, so same manufacturer part number, and then go and find alternate parts or parts that have the same form, fit, and function as that particular part, and then find suppliers for them. So all of that is now automated and being done using the AWS machine learning algorithms that we have developed.
So if you're curious about what you've heard Peter or me describe and you'd like to get started, then I've got a number of suggestions for you. And also a reminder that we have the chat console open here, and feel free to ask your ask your questions in the chat here in the GoToWebinar software. If you'd like to get started, then I'd really encourage you, based on what other customers tell us, to learn by doing. And I'd encourage you to get started with a proof of concept around machine learning. You may also be interested in understanding how to approach the migration of SAP to AWS. And if that's the case, we can help you with a migration readiness assessment, which is the first step in our broader framework for accelerating migrations, and it'll help you proceed with confidence. On behalf of Utopia Global, I can offer to you that a guided proof of concept with their innovations around machine learning and SAP is available, and we'd be pleased to refer you to Utopia Global. If you're interested in what you've heard today, then please grab your phone and use the QR code shown on the right-hand side of this chart here. So on behalf of AWS, firstly, I'd like to thank you, Peter, for sharing your experience and demonstrating your innovations around machine learning and SAP master data. And congratulations to you and your colleagues on your success at Utopia Global.
Thank you very
Kristen,
much.
thank you very much for hosting our webinar today, and for our attendees, thanks for joining. Just a reminder here that you can continue the conversation with us. We'd be pleased to engage you. There are some social media links on screen in front of you here, and if you have the QR code still saved in your phone from earlier, we'd be pleased to engage with you there. Thanks very much for joining us. Good morning.
Thank you, everyone. Bye-bye.